Is it clear now? Is clear? Okay, guys. First of all, we are going to start with the first question, A part. Okay. Now, everybody just listen, guys. In this question, if you look, you have to find out the order of reactant. Okay. Then you have to make the rate equation, the K value, and the units of K. The same thing. Okay. So if you want to find out the order of phenacyl chlorides, okay. So you have to choose the two experiments in which the concentration of phenacyl chloride is changing, whereas the concentration of NaOH that would remain constant. So this one and this one is constant, but this one is changing. So the experiment 1 and 2 I have chosen. Okay. Now what should you do? Use the formula C2 over C1. C2 is the bigger concentration. Don't write the formula in your paper or the answer. This is my self-made formula, so please don't try to use it in the paper. Okay, you just put the values up there. So 0.03 divided by 0.02 its power n, that is equal to when 0.03 concentration was there, we got the rate 1.5. And when we got the concentration 0.02, the rate is 1. So it would be 1.5 power n is equal to 1.5. Its power is 1.5 and 1.5 that would be cancelled. So your order is 1 for phenacyl chloride. Did you get it? But this is very simple. If you want to find out the order of the phenacyl chloride plasma, you should choose the two experiments in which the concentration of phenacyl chloride is changing, and this one remains constant. So this is constant, this is constant. Okay, so these two are changing. Okay, so use these two experiments. Okay, put the concentration 0.03 and then divided by 0.02, and then rate of this one 1.5 and then rate of this one 1. So if you solve it, you will get the answer 1. Did you get it now?
Yes, sir.
Okay. Now, my dear, the concentration of phenacyl chloride is 1. Now, the next thing is a little bit hard for us. Why? Because when we want to find out the order of NaOH, its concentration is changing all the time. It's not becoming constant. So this one creates a problem for us. Now for these type of the question, I'm going to tell you a method. And what is that method? You should choose the two experiments in which the concentration of NaOH that is changing. So it is changing in experiment 2 and 3. Okay. Now what should you do? You should take a supposed experiment, right, as a pair in between those two experiments 2 and 3. Okay. In this supposed experiment, the two values 2 and 3 experiments are given. So in the supposed experiment, you should write the second value of that reactant whose order you have calculated. So this is the first value, this is the second value. So second value you should write in the center 0.025. Okay, and just like that, these are the two values. So write the first value of that reactant whose order you have to calculate 0.10. Okay, and then by ratio method find out the rate. How could you find out the rate? The order you calculated for the reactant, those concentration you should take. So at 0.03, what was the rate? 1.5. And at 0.025, what could be the rate? It is x. So if you cross multiply it, my dear, you will get 1.25. Just calculate it and let me know. Is it 1.25? Yes, sir. Okay, now if you look up here, my dear students, this value is constant. Have a look. This is 0.025. This is 0.025. But this one is changing. Okay, and this one is changing as well. So you should write 0.2 divided by 0.1 power n, that is equal to 2.5 divided by 1.25. So if you solve it, 2 power n is equal to 2. So this one would be cut. N is first order. So this is also the first order. Yeah. Did you get it? So if you want to take the screenshot, you can take it, because I'm going to give you the same kind of the question that in the next one. Yeah, this is the question. Question number 12. Now you should practice this question. Everyone should try it, beta. In chemistry, practice makes a man perfect. If you do the question, then you will understand the concept. Okay? गलत करें, do the wrong thing, then you will get it. Your time starts now. Giving you 3 minutes. Okay? So how could you find it out? These two are constant. These two are the constant values, but this one is changing. Okay, so use these values. 0.2 divided by 0.1, its power n, that is equal to 0.2 got the order, rate 2, and this one got the rate 1. Okay, so 2 power n is equal to 2, so this is first order. So this is first order reactant. Okay, now if you want to find out the order of this one, this is not becoming constant. Okay, so now in that case you should make a suppose reaction in between those two experiments where the concentration of this OH minus that is changing. So it's changing in between those two experiments. Okay, so here you should make a suppose experiment. Write the second value of that reactant whose order you have calculated 0.40. Write the first value of that reactant whose order you have not still calculated 0.015. Now by the ratio with the rate on
सर एक क्वेश्चन था
जी जी
सर, ये 0.40 क्यों है? यहाँ पे 0.20 नहीं आना चाहिए था सर?
और भाई सेकंड वैल्यू ये वाली है, ये दो वैल्यूज हैं, जिसका ऑर्डर निकाल चुके हो उसकी सेकंड वैल्यू लिखनी होती है सपोज की जगह पे, बताया तो है
सर सेकंड सर मैंने सर इन दोनों का वो जो हाफ लेके सर तो जो आता है वो लिखा है सर।
नहीं नहीं बेटा,
सर मैं समझ नहीं।
ये दो वैल्यूज हैं मेरे चांद, ये 0.2 और 0.4, तो ये जो सेकंड वाली वैल्यू है ये बीच में लिख दे। जिसका ऑर्डर तूने नहीं निकाला, ठीक है, इसका नहीं निकाला, तो इसकी ये दो वैल्यूज हैं, तो इसकी ये पहली वाली वैल्यू बीच में लिख दे। सिर्फ इतना सा काम है, और आगे जो है ना वो रेशियो बनानी है। जिसका ऑर्डर तुम निकाल चुके हो उसकी कंसंट्रेशन और रेट की रेशियो बना लो। तो 0.2 पे कितना आपका रेट आ रहा है 2, तो 0.4 पे कितना रेट आएगा माय डियर, x क्रॉस मल्टीप्लाई करने कितना आ गया 4, तो यहाँ पे 4 आ जाएगा। ओके, नाउ इफ यू लुक दिस वन इज कांस्टेंट एंड दिस वन इज चेंजिंग। ओके, तो इसके चेंज करने से ये भी चेंज कर रहा है, तो इसको यूज कर लें 0.03 डिवाइडेड बाय 0.015, इट्स पावर n इज इक्वल टू R2 ओवर R1 है। ठीक है जी, तो R2 आपका 8 है और वो 4 है, तो इसको सॉल्व करें पावर n दैट इज इक्वल टू 2, सो इट्स आल्सो द फर्स्ट ऑर्डर। डिड यू गेट इट?
यस सर।
चलिए, ये तो एक मेथड था, ठीक है जी, ये पहला तरीका था। Okay guys, let me tell you, there is a question, I think it is not present with me at that time. There is a question in which the concentration of both reactants is continuously changing. Okay, so now what should you do in that case? There is nothing becoming constant in both reactants. So you should take any two experiments for one reactant and find out the order. If you get any order, so that reactant has got that particular order, whereas the second reactant would be 0 order. Keep remember. If the values of all the things are changing continuously, so let me make a question for you up here. Let's suppose I haven't got that type of question with me. Let's suppose if this is the question, my dear, this is the question. Okay, so this one is continuously changing 0.020. Okay, and this is 0.030. Okay, this is 0. If you see, this one is changing and this one is changing as well. There is no reactant becoming constant. So in that case, you could take any two experiments for this one. okay, and find out its order. If you get the order, so it means that reactant has got that particular order, like 1. And if you find out, if you did not get the proper order for that, let's suppose 2 power n is equal to, uh, here you write 108.3. So this is something unusual. Okay, this is something unusual. So it means this one is zero order. Okay, then find out the order of this one by taking the two values. You will get the order for this one. Okay, so one of the reactant would be zero order and the other one should have some order. Okay, if I find such kind of the question, I will display it for you. Okay, so everyone got it, beta? With the next part of the reaction kinetics. Okay, this was the first method to find out the order of reactant. Okay, and that method is called as the experimental method. In the experimental method, you are given a table in which the different experiments are given, and you got different reactants, and the rate is given, and you can find out the order of reactant, okay, and make the rate equation, K value and K units. We have calculated all those things. But today, my dear, we are going to start with the next method to find out the order of reactant. This is the second method. Okay, so second method is basically the graphical method. So graphical method is basically the second method. To find out the order of reactants. So I'm going to draw a shape up here, okay? So I'm going to draw that particular shape. So I want you people to draw it with me. I'm not going to talk with that, okay? I will just draw it, and after that, I will make you understand how you can calculate the order of reactant and the rate equation K and units of K, all these things from that particular information, okay? Now, this is the information, okay? You are being provided, and by using this particular information, my dear students, you are supposed to find out the order of reactant. You find out the, you have to make the rate equation. You have to find out the value of K, and you have to find out the units of K by using this information. The last method we have done, I'm just going to draw it for you. The last method was like this tabulating form in which the different experiments 1, 2, 3, 4, 5. So you are being given the different reactants like reactant A concentration, B concentration, okay, and here you are given the rates, okay, all these values are given, and you calculated all those things. We calculated last time, okay, but now I'm here. You are given this graph, okay, and now you have to calculate it, all those things. Now just I'm going to make you understand what is this graph mean. First of all, this is a reaction. In this reaction, ester and OH minus, they are going to form carboxylic acid and alcohol. So we are not concerned with these products, okay, because in the rate law or rate constant, you just need the concentration of the reactants, okay? So ester concentration and OH minus concentration you need, okay? Now in this graph, my dear students, what is given? Along the y-axis, so this is the y-axis. Along the y-axis, he has taken any one of the reactants like ester concentration, okay? And he has taken the two different concentration of the second reactant, OH minus concentration. The two concentration are given. If you take OH minus concentration 0.1 mole per dm cube, you will get this curve. This is 1K. This is curve A. Okay. So if you got the concentration OH minus 0.2, you will get this curve. Along the x-axis, my dear students, you are given the time in minutes, but it's not necessary they give you time in minutes. They can give you time in seconds. They can give you time in hours. They can give you time in days. So that's their choice. Okay, so you have to see along the y-axis which units they have used. Okay, now by using all this information, we have to calculate the order of reactants for the two reactants ester and OH minus. Okay, so let's start. First of all, the reactant whose concentration is drawn along the y-axis, ester. If you want to find out the order of reactant with respect to this reactant who is drawn along the y-axis, okay? So how could you find out its order? You can find out its order by a method which is called as the, if you want to find out the order of reactant of ester, so you can find out it by half-life method. And half-life method, this is very simple method. These are the two curves. That curve which is very close to the y-axis, just choose that particular curve. I'm going to choose this curve. Okay? So now what I'm going to do? Everybody just listen. I'm going to take the initial concentration. The initial concentration, anyone could tell me what is that? 0.7. Okay?
0.7.
Yeah, and the time is, this is 0 minutes. Okay, now make the half of this 0.7. What it would be? 0.35. So 0.35 would be present up here, like that. How much time is required for the concentration of 0.7 to become half? That would take 4 minutes. How much time is required? 4 minutes. Did you get it?
Yes, sir.
Okay, now this is 0.35. It's 0.35. Now make the half of this 0.35, guys. What is that? 0.175. So 0.175 is present around here, like that. Here, okay? 0.175. So if you do it right here, okay? So how much time is required for this gap? This gap. Come on. 4 minutes. Don't count it from the start. This gap, because 0.35 is this one and 0.175 is this one. Okay? So this gap, my dear, that is again 4 minutes. So if the equal interval of the time is required for the given concentration of the reactant along y-axis to become half of its initial concentration, my dear, then it would be first order reactant. Second thing, if the time would become double, let's suppose in the first when the thing was half, first time it takes 4 minutes. In the second, when it becomes half, it takes 8 minutes, and then it takes 16 minutes. The time would become double. Okay, when you are going to half that particular reactant, so then that would be the second order reactant. And if there is a straight line like that, straight line from y-axis to x-axis, straight line. So this thing shows the zero order reactant. If you got the curves, like curves, then it could be first or second. But if you got a straight line, so straightforward, that is a zero order. Did you get it?
Yes, sir.
Online students, did you get it?
Yes, sir.
Okay, I'm going to write this thing up here. So you could copy it, my dear. If the concentration of reactant along y-axis become half of its original concentration and equal intervals of time are required, then it would be a first order reactant. First order reactant. Okay? And then the second point, if time would become double. Every time for initial concentrations of reactants along y-axis to become half of its initial concentration, then it would be second order reactants. Okay, and then the third one, if there is a straight line from y-axis to x-axis for given concentration of reactants along y-axis, then it would be zero order reactants. Guys, just listen to me again. Take the initial concentration, make the half of it. Okay, and whatever the time span is required, just note it down. And then make the half of this value. Okay, so whatever the time span is required, note that value. If equal interval of time is required for the concentration to become half of its original concentration, then it would be first order. But if here for the first half is 4 minutes, the second half would take 8 minutes, the third half would take 16 minutes. So time would become double every time. Okay, so then that would be the second order reactant. And if there is a straight line, okay, from the y to the x-axis, so that would be the zero order reactant. So I would suggest you, because this whole thing requires, the solid thing. I have sent you the worksheet. आपको वहां पे ग्राफ वाले जो क्वेश्चन नजर आ रहे हैं, I would suggest to all my students online. So please make the photocopy of that particular part of the worksheet where the graphs are given. So make the photocopy of that. The students which are physically present in my class, I will give them the photocopy, because tomorrow when we complete this one, we will do the practice, because that thing couldn't be done online. If I draw the line, I won't be able. Okay, so please, everyone should have the solid thing in front of you. तो ऑनलाइन स्टूडेंट्स कल एक काम कीजिएगा, जो मैंने वर्कशीट आप लोगों को सेंड की हुई है, उस वर्कशीट की जो ग्राफ वाले क्वेश्चन हैं उनको आप लोगों ने कॉपी कर लेना है. कॉपी मीन उनकी एक प्रिंट आउट ले लेना है. ओके.